again. All right, for the solution to this, we want to test for absolute convergence. I'm going to try the ratio test. So I'm looking at the problem, and I'm seeing this, that a sub n equals -1 to the n times n cubed over 3 to the n. So this part of this series, that's a sub n. Well, what's a sub n plus 1? All of the n's become n plus 1. So -1 to the n plus 1 times n plus 1 cubed over 3 to the n plus 1. And I have to form the ratio. You could, if you write limit n approaches infinity and you write equal signs, you got to make sure you write everything correct. I'm going to go after this ratio first, a sub n plus 1 over a sub n. So, and this absolute value. So it's the absolute value of -1 to the n plus 1 times n plus 1 cubed over 3 to the n plus 1 divided by a sub n, which is -1 to the n times n cubed over 3 to the n. And I've written it like this for years, and from my Calc 2 students, I have learned, you know what? I've seen Calc 2 students do this. They go straight to this next little version. Okay, -1 to the n plus 1 times n plus 1 cubed over 3 to the n plus 1. Now, this is divided by a sub n. So how do you divide by a fraction? Multiply by the reciprocal. I've seen Calc 2 students just go straight to multiplying by the reciprocal. Nothing wrong with that. And now I'm going to simplify this fraction. A lot of times we'll form 3 separate fractions in this case. A fraction with the -1s. And since it's all multiplication, I can do this. So -1 to the n plus 1 over -1 to the n. And then n plus 1 cubed over n cubed. And then 3 to the n over 3 to the n plus 1. Get the pieces that are similar to each other, one over the other. And then I'm going to reduce this. Now, because I have absolute value, what happens with these -1s? They're gone. And then I'll have this fraction times this. How does this reduce? It's 1 over 3. So there's a couple of ways you can think about that. N plus 1 cubed over n cubed. What I saw a lot of when I took calculus is they did this. 3 to the n over 3 to the n times 3 to the first. Because my exponent rules, here I have the same base. I would add n plus 1, I get n plus 1. You could also use the exponent rule and subtract the exponents. However you do it, those cancel, 3 to the n over 3 to the n, and I'm going to be left with 1 over 3. So my ratio reduces to the absolute value of n plus 1 cubed over n cubed times 1/3. And I could take off the absolute value at this point because n is going to infinity. It's starting with 1. Okay, but I'm going to keep them. Now, from the ratio test, find the limit as n approaches infinity of the ratio of a sub n plus 1 over a sub n, and that's the limit as n approaches infinity of n plus 1 to the third over n to the third times 1/3. Only one part of this do I need to worry about, the n, this fraction right here. What is that limit? No? That's going to be 1. Because you know what? I'm looking at degrees. The degree of the top is 3. If I FOILed all of this out, multiplied n plus 1 times n plus 1 times n plus 1, I would get n to the third. That's going to take control of the top as n goes to infinity, n to the third in the bottom. This part, the limit's going to be 1. So this limit is 1 times 1/3, and that equals 1/3. I got a number. It is less than 1. So by the ratio test, this series converges absolutely. By the ratio test, this series, as n goes from 1 to infinity, -1 to the n times n cubed over 3 to the n, converges absolutely.